Hello, I'm Vikas Mandar. This video is showing how to compute multiple correlation and multiple regression result. This education material is important to teachers, students, researchers, and many stakeholders who can apply this knowledge on their respective study area. Before computing multiple correlation coefficients, we have to manage and compile our data into a single table. Here, the table of our data shows the data regarding independent variables x1, x2, x3, x4, and x5, and dependent variable of y as well. To compute the multiple correlation coefficients, we have to go functional bar on data. Then after, choose the data analysis. Then after, a small interface box will appear on our screen. Our motive is to compute the correlation, so we select the correlation and then OK. Here, the input range and output range have been appeared. The purpose of input range is to insert our data, whereas the output range is to show the output on particular cell. So we insert our data from x1 to y up to the number of 30 observations. Then after click the label and also click the output range. So we are going to show our result on cell L7. Then OK. So here the correlation coefficient matrix has been appeared as an output form. To make analysis easier, we reduce the digit after the decimals. Now, to compute the multiple regressions, in the same way we go on data, then after data analysis. So now we choose the regression. Then OK. Another small interface box will appear where the input range. To compute the regression, so we have to clearly define the independent variables and dependent variable. Here, x1, x2, x3, x4, and x5 are the independent variables, whereas y is a dependent variable. So to insert the input at y range, we select the data of y. Insert the data on the cell of input x range, then we have to select the data of x1 to x5. Then click on the label. And then after, select the output range to show the result. Then we select L19. Then after, click the OK. Then after, we have the regression result in three table. Which are a regression of model summary. This part is the model summary. And this part is the result of ANOVA. And the third table is to show the regression results. Let's begin to analyze the correlation and correlation results. Here, the dependent variable is y. Dependent variable is y. The relationship y is negative with the variables x1, x2, x3, and x5, whereas there is positive relationship between y and x4. It means that when x1, x2, x3, and x5 increases, then the value of y decreases. There is inverse relationship of y with the variable x1, x2, x3, and x5, but positive relationship with the variable x4. The one more thing you have to note that diagonal, the value presented in diagonal is 1, which is perfect positive. It means that the relationship of one variable to itself always be perfect positive. So the correlation coefficient is resulted 1. And analyzing the multiple regression results, here multiple R is resulted 0.831, which is above 0.70. That means dependent variable y is highly explainable by selected independent variables x1, x2, x3, x4, and x5. Then after R square, it is the multiple coefficient of determination, which is resulted 0.690. It means that 69% of total variation in dependent variable y is explained by independent variables x1, x2, x3, x4, and x5. Remaining 31% is unexplainable, which is due to other factors that have not been taken into consideration in the regression model. Adjusted R square is 0.625. It represents that if another key independent variable is introduced in regression model, then R square value will decline from 0.690 to 0.625. Standard error is found to be 0.320. It means that there is a difference of 0.320 between actual value and estimated value of y. Observation is resulted 30. That means we have inserted 30 observations in our data. ANOVA, we can see the value of F statistics 10.6855, whereas the significance value is 0.000. It means when the significance value of F statistics is found to be less than 0.05, that means significance level of 5%, it means that the regression model is statistically fitted because p value is found to be less than 0.05. From the third table of regression result, the first column represents the question of the variables. The intercept means the constant value, which is resulted 8.775. It means that if all selected variables are held 0, then the value of dependent variable y will be 8.775. The quotient of first independent variable x1 is minus 0.091. It means that variable x1 has negative impact on dependent variable y. In the same way, variable x3 has also a negative impact on variable y. But remaining variables x2, x4, and x5 have positive impact on dependent variable y. Analyzing in another way, the quotient value of x1 means when x1 variable increases by 1%, then value of y will be decreased by 0.091%, and it may deviate by 0.027%. It indicates by standard error. Similarly, the value of x2 0.002 indicates that when x2 variable increases by 1%, then value of y dependent variable will be increased by 0.002%, and it may deviate by 0.007%. So we can analyze the variable one by one variable in this way. To find which variables are significant and which variables are not significant, we have to see p-value statistics. P-value statistics, if we have significance level of 5%, then this variable will have significant impact if the p-value is found to be less than 0.005. Otherwise, that will be insignificant. So looking at the p-value, variable x1, variable x3, variable x4 are found to be significant determinants of variable y. Remaining variable x2 and variable x5 have insignificant impact on variable y because their p-value are higher than 0.05. So in this way, we can analyze the regression result. So regression model can be appeared as follows: y equals to a plus b1 x1 plus b2 x2 plus b3 x2 plus b4 x4 plus b5 x5 plus e. E means error terms. So we can develop our regression model looking at the question results.